All right, well, good morning, everyone, and welcome to our Mastercam event. This is from MCAM Northwest. We're your Mastercam reseller in this area. Today, we're doing a hybrid event here at Chemeketa Community College, which is an awesome place. I do want to take a moment to just kind of shout out the school. Sheldon's been awesome, great guy to work with, and they've got a really great program here. We really, really like it. We know that students coming out of here get snapped up pretty quickly for jobs, so that's a really good sign that they've got a great program here. So I did want to just mention that quickly. So this is a hybrid event. This is a little bit different than we normally do, being here in person and also seeing you guys on the web. So it does mean that we're going to do this a little bit differently, but we're still going to be able to cover the same topics. What I'm really looking forward to is having some interaction, not just online, but also in person with you guys. So a little bit of quick introductions. My name is John Stauffer. I'm an apps engineer at MCAM Northwest. I've been in manufacturing for about 12 years, and I've been at MCAM for about 4. And we also have Kyler Ackroyd with us today. He's our newest sales guy. Kyler, did you want to say hi?
Hello, everybody.
If you couldn't hear Kyler, he said hi. So Kyler is going to be here to help with monitoring questions from online. So if you have any questions online, feel free to type them into the chat at any time. He'll be there to voice your chat for you, and then I can answer that. If you guys have a question here live, feel free to raise your hand at any point, and we'll just get right to you. One other quick note here before we get started on our event, which is all about libraries. If you are not able to stay for the entire presentation, I really hope you guys live are going to stay. But if you're not here in person and you can't stay for the whole thing, a recording of this will be available at themcamnw.com/videos. And we should have that up sometime next week. All right, so let's go ahead and roll the slides. All right, so today we are talking about how we can improve our programming efficiency using libraries, right? This is, oh, there we go, good. All right, so Mastercam has a bunch of different libraries that are built into it, and then we can also approach the way that we program a little bit differently to make our own sort of libraries. So by combining these two methods and thinking about what we want to do, we can really improve our efficiency. So a few points I want to go over today. What are the native library types in Mastercam? We're going to talk about other types of what I think of as libraries for Mastercam. I want to briefly go over the Mastercam.com tech exchange. And then I want to give you a few examples. We're going to talk about loading fixtures, ways that we can do this really effectively. We're going to look at standardized operation sets, so ways that we can take something that we make a similar version of multiple times, and how can we be very effective with that. We're going to talk about loading saved defaults. This is a new feature for Mastercam 2024 that is really awesome, and there's a lot of power to this if we take some time to set it up correctly. Then we're going to talk about process hole a little bit. I'm not going to go into super deep detail on that because we have covered process hole several times recently, and you know, I don't want to kick a dead horse, but it is a really cool feature, and it's very powerful when you set it up correctly. So I do want to go over it. And then we're going to wrap this up by talking about how we can use these libraries and these techniques for quoting purposes, because we think that by using this correctly, you can get your quoting done way quicker and more accurately. So I really like that. These first few points are going to be a lot of talking, not a lot of showing. We're going to get to the showing in a couple minutes, though. So first up, what are the native tool libraries in Mastercam? So the native tool libraries, there's several, and we're probably not covering all of them here, but these are the ones that probably most people think about, and they're the ones that probably make the most impact. Tool libraries is the most obvious one. So a grouping of tools, and how is that tool defined? You've got your diameter, you've got your cut length, you know, you've got your number of flutes, or your turning tools, right? What does your tool steel look like? What does your insert look like? What's your radius? So tool libraries, you can do a lot with them because there are some settings within Mastercam that allow you to really utilize them. Kyler, if you want to switch to my screen really quick, we'll do just a quick example. So I don't even have anything on screen yet, but I just want to show you an option here. So in our tools, actually, if I just go ahead and I'm just going to sketch something on here. This is just something to look at. That's all that really matters. Now for our tool, I'm going to grab a tool from the library, and this will just be a regular end mill, 1/4 inch. Now, if I look at the definition of this tool by going to Edit Tool, on the next page, in this lower right section, we have a couple checkboxes to tell it whether we want this to be a rough or finish tool, or both. And we can give it values for our rough XY step over, a rough Z step down, and then our finish XY step over and our finish Z step down. And this is as percentages of the tool diameter. Now, the reason that's important is because in our machine group properties, if we take a look in the tool settings, which is the second subgroup, that'll take us into job setup or machine group setup. And down in this lowest section, there's a checkbox here for use tools, step, pec, and coolant. So when you have that turned on and you have your tools all predefined in a library, you can pull lots of information in just from picking your tool. So when you're setting up a tool library, consider setting up your tools in a manner where they're very specific. You don't use a general 1/4 inch end mill. It's which 1/4 inch end mill. What cut length does it have? Which manufacturer did it come from? What coating does it have on it? What material is it defined for? By having it down to that level, you can really dial in exactly what the settings should be for that tool. And in combination with this checkbox, you're going to get through your programming quicker. Now, that's not new. We're still a minute off from getting to the new stuff, but I did want to mention that because I think it's important. Let's go back to the slides. The next one is material libraries. Material libraries have been around quite a while, and they used to be pretty popular, but they've fallen out of popularity. The main reason for that is that the point of a material library was to take one tool and adjust its speed and feed based on which material you're cutting. And you did that by adjusting those feeds and speeds by some percentage value. And that worked pretty well when you had an carbide end mill that you used for every material, right? But we don't really do that anymore. That's not how carbide technology has evolved. Modern carbide is dedicated. You have one tool that's for a fairly narrow band of material these days. You can use it outside of it, but it's not what it's designed for. So with that, I don't really use the material libraries anymore because I've found that just building tool libraries with the correct settings in there is a more effective way to go about it. Now, it's not to say they're useless. If you like that method, you can still use it, absolutely. I just don't think it's as effective. But we did recently have a customer who had a laser machine. And what's kind of cool about lasers is that depending on how they work, they may not need any Z information. As long as you tell them what the material is, it can set a bunch of things for you. Well, we figured out that what we could do is in the material library, we could create a new material and give it a specific description with specific numbers and letters that are meant to work with that laser. And when you pick that material, it automatically could take that information, pull it into the post, and process it correctly to give that information to the laser. So that's one way you could use it. And that's another reason why it's good to talk to us. Like if you guys want to do something and you don't know how to do it, talk to us, because that's not something that is, you know, native Mastercam sort of thing to do, but we figured it out because we knew what to look for. So give us a call if you guys are wanting to do anything cool like that. Operation libraries. This is a set of operations that are basically defined to work for a particular machine. So your router has X tool paths to it. Your mill has basically the same things, minus saw and block drill. Your lathe has your turning tool paths and also your milling tool paths because a lathe definition can do both. Probably not much to edit there. In some cases, especially in mill turn, there can be uses. The most popular one I've seen is to create multiple part-off operations so that you can just easily select them from your POCO trees. But that's kind of it. The ops default libraries is where you get the default settings for the toolpaths. And in the past, basically the way that this worked was if you wanted to go back to defaults, you could click a button and it would bring those defaults back. If you wanted your defaults to be different, you could change them and save them. And that way, you know, you have your own defaults, which can be helpful, especially if you're working within, you know, kind of a single material or process. If you are working in multiple materials, it's less useful. But when we talk about loading save defaults, there's a big change and it becomes much more useful. Finally, we have component libraries, which is a Milturn specific thing. That's what holds your chucks, your chuck jaws, your locators, things like that, collets. So if you're using that kind of machine, that's a library that's important for that. We don't have time to go over that today. It is an entire presentation on its own, so we're going to skip that. So let's go to the next slide. So the other types of libraries, I think, can be arguably more powerful, or they can be used in conjunction with other libraries really well. So the first one is standardized operation sets. So this is a set of operations that you use on a regular basis in the same order, right? I've got a really cool example for this coming up, so we'll go over that. Next, we have process whole files. So process whole is new for 2024. Has anyone heard of this before? No? No hands? None? All right. Process whole is pretty cool. We can essentially pick a solid whole, and based on how it's defined and pulling from another file, we can automatically bring in toolpaths that will cut that hole correctly. And we have options for how we want to do that. If you have one hole that you cut 3 different ways, you can have it done 3 different ways. It's up to you. It's very cool. We're going to talk about that a little bit too. Fixture libraries. I loosely call this a library. This is a folder with a collection of files in it that is organized in such a way that it is useful. If you're not doing this and you use a lot of fixturing, I am going to show you how I do it, and hopefully you like it, and maybe you have a way to tweak it and do it your way. That would be awesome. I like to see how other people do this. To me, this is what makes the most sense, and we'll go over that as well. And then finally, operation defaults from other files. And this is using the new load save defaults option within Mastercam. Essentially, what this would allow us to do is if I want to run an OptiRef toolpath, I don't have to set every parameter. I can just pick OptiRef, pick a set of defaults that I want based on another file, pick my geometry and hit green check, and that's it, and you're done. Super useful. And I think that if you take the time to set it up, it's going to be very, very good for time savings. So let's go ahead and go to the next slide. Briefly, I do want to mention the Mastercam.com Tech Exchange. Has anyone used that before? No? All right. So the Mastercam.com Tech Exchange is a place where you can go to online, Mastercam.com. You go to the community section and you'll find the Tech Exchange in there. The Tech Exchange gives you access to download lots of different kinds of files. You can get sample files so that you can test out things that CNC has tested out for themselves. You can get tool libraries. These are predefined tool libraries from companies that are very detailed, very nice, fully written out. You can get component libraries. So if you're in a Milturn environment, let's say you need to get a specific model for your tooling block for your machine. We call that a locator in Mastercam. A lot of times you can define those models right on the Tech Exchange. You don't even have to define it. You can just bring it in and use it. It's great. So the Tech Exchange, while you can use it for full libraries, I don't know a lot of people who actually use a single brand of tool for everything that they do. That's a little unrealistic. But what you can do is if you know that you have some tools from this line of products and a tool library exists for that, well, there you go. Get the library and pull the tools you need out of that one and into your own custom library. Then you don't have to define all those tools, right? It's so much easier. So I think that that's really the benefit of the Tech Exchange, is being able to find pieces so that you don't have to do as much. Okay, so I'm done talking constantly. We're going to get into some actual examples. Do you have anything in the chat?
Nope. Jeff posted the link for the Tech Exchange.
Thank you, Jeff. And if you guys have questions at any time, feel free to raise your hand. If you think I'm going too fast, let me know. All right, so we can go ahead and go back to my screen. So let's talk about loading fixtures. So when we're in the shop and we're making things, we need to put our parts in fixtures, right? Some kind of fixture, whether that's a vise or some custom-made fixture or something, right? But we need to think about the way that we store this information so that we can get to it effectively and use it effectively. So I'll show you the way that I've handled this. I'm going to go to my shared Mastercam folder. And in here, I've got all my folders, and I don't know if you knew this, but you can actually create your own folders inside of the shared Mastercam folder. You are not locked out of this. I've created a folder here labeled fixtures. And if I go into that, I've got a couple of folders here. Now, at this point, this really starts to divide into how do you want to do this, right? But I'll show you my example. So I've got a couple of folders, one's for individual pieces and one's for standard configurations. So if I look in my individual pieces, I've got several files here. And so I might start with, I've got a new job and I know that I'm going to be working on my 4-axis. So I'm going to bring in my 400 millimeter tombstone. So I bring that in and here's my model. Now, I do want to point out that when you're doing this, you're saving your fixtures, it's a really good idea to try to limit the amount of detail that you have in your files. Not too long ago, 2 weeks ago or something like that, I put out a tech tip about how that can affect your files. We had one version of a fixture that was put together that was something like 15 megabytes or something like that. And then the same thing with slightly less detail, but still perfectly good for a collision model was like a couple megabytes. And it opened way faster. It wasn't 30 seconds, it was 2. So it makes a big difference. Here you can see it's pretty minimal. I just have, it's pretty basic. There's probably a little detail here that I could get rid of, but it's how much work do you want to put into it as well. There's a bit of a balance there. So that's my first piece, and then I might want to bring on more to that. So I'll go back to here, and what is the next thing I want to add? Well, I might want to put my vise base plate on here. So I can hold Control, click and drag this down, and that merges my base plate in. Now in this example, I happen to have it in position. A lot of times it isn't, and you have to move it around, and that's okay. It's not too big of a deal with all these tools we have inside of Merge. But this way, I can grab my pieces quickly and then just put them where they need to go, move them, rotate them, translate them as needed. So that works well for if we're building something totally brand new that we've never done before with pieces that we own. But if you run the same sort of standard configuration frequently, then save that as a file too. So in my standard configuration, I've got this built. And this file has 8 self-centering vices on subplates on my tombstone ready to go. And this works for tons of different jobs. So it's a good starting point for wherever I want to go. At this point, I can bring in my model, put it in place, add some stock, and get tool pathing. Everything's ready. You can even go as far as in your planes. I don't have this set, but you could add in planes if you want to, if you have standard ways you like to manage your planes in here. So the idea of a fixture library is to just have your pieces ready so that you can bring them in quickly and easily and use that merge function to put everything in place. Any questions so far?
Are you downloading those things or did you create them yourself?
So you asked if I downloaded those things or if I created them myself. Yeah. So it's a mix. So sometimes you can download them and sometimes you have to create them. It really depends on what that company offers. Some companies are really good about putting out excellent quality models that are on size, they're minimal detail, they're great. Other companies, they'll give you a nice model, but they're really detailed. And then you kind of want to go through and pick those clean. That's what I like to do. Make sure to check out the tech tip that I did to see a little bit more on that. Or some companies either don't offer models, or if they do offer one, it's some horrible STL. And in those cases, you're going to build it yourself. But the thing to remember with fixturing is that you want to create a collision model. You don't need this to be perfect. You need it to be size accurate and where it needs to sit so that collision checking works. And that's really it. It doesn't have to be fancy. If this little corner cut right here isn't going to be critical to your operation, don't model it. It's fine. You know, it's too much work. I try to keep everything as simple as possible. Does that answer your question?
Yes.
Awesome. Cool. Okay, I think we can go back to the slides. So next up is standardized operation sets. Okay, So let's say that you're working in an environment where you make a similar part on a day-to-day basis. This is something that I resonate with a lot because my very first job as a machinist, I was working in this shop that made what are called wave solder pallets. These are fiberglass boards that are pressed with resin, and then you cut a pattern out that has a shallow pocket for a PCB, deeper pockets that cover components that are on that PCB that are mounted, and then it's got through holes where you can have leads that are poking through the PCB, and then waves of liquid solder lap up underneath the board to solder those pieces together automatically. We did so many of these things, it blew my mind. There were so many. And it was the same product over and over again. It was the same features over and over again, but every design is custom. Every design is unique. So there's a lot of people who do stuff like that, right? Similar work, but everything's customized. So in that sort of a case, I really like standardized operation sets because we can get these sets of operations, bring them in quickly and easily, and then modify what we need to get the output we're looking for. So this is a big time saver. It keeps your work more consistent. This is also great for programming with multiple programmers. If you have a lot of people that are doing the same sort of job, everyone does a similar job, as opposed to this person does it this way, but this person does it this way. You know, let's have a standard process, right? It makes it easier for people to walk in later and figure out what's going on. And if you have an update to your process, you can update one spot and then everything from that point forward is made with that update. So I think that's a great way to go about it. Kyler, why don't we go ahead and go back to my screen while I find my file. Okay. Oh, actually, you know what? I need to go here. So this is another example where I've created a folder in my shared Mastercam. I call it processes. And this has my operations set for wave solder pallets. So I'm going to bring this in. And I want to point out that what you're seeing here, this is not super representative of what we're actually making. This is the bare bones of what we're looking for in terms of features. That's really it. You don't have to be complicated. You don't need a crazy part to do this. All I knew is that you generally have a shallow pocket that fills that you fill in with the PCB. Great. Doesn't even matter how deep it is. As long as you have an even shallow pocket, it's good. Then you have deeper pockets. Some of those have islands. I know the tool sizes that we're using, so I might want to size some of those islands close so that big tools can't get in, but little tools can. And I have through holes. And with those through holes, I also wanted to make sure at least one of them was too small for my largest tool. So this was literally something I sketched out in wireframe in about 2 minutes that roughly approximates the types of features that I'm working with on a daily basis with these boards. So now let's go back to here, and I'm going to pull in this file right here. And this may take a moment to load. There's some data here. All right. And you know what? Let's adjust the color of this. Let's make it a little brighter, a little easier to see. So this is a more standard wave solder palette. I've got a whole bunch of these features, but I still have one shallow pocket, some deeper pockets, some islands, maybe some even deeper pockets, and some through holes. But with the other one that I made and the tool paths that I made that work for it, we can take those tool paths from the first file, bring them in, reassociate our geometry, and be done with it. So the easy way to do this, let's double check first. I want to make sure our stock is set up. Looks like it. Great. So I'm going to right click and import. I'm going to go to my shared Mastercam folder, find my processes folder. I have to switch my file type to Mastercam files, and then I'll find my operation set, and then I'll bring that in. Now, I'll be clear. This is not a new thing. We've had import for ages, but I'm showing you a way that you can use this as a library to make it effective for you. I'm going to grab all those operations, hit the blue plus, say OK here, and close. Now, because I'm familiar with it, I know that the first thing I'd like to do is update my stock model to figure out the starting size of it. I want it to match my stock setup. So I'll say rectangular stock setup, green check. And it's going to give me an error because my previous toolpath isn't finished, and it depends on that. That's OK. At this point, I'll go into the geometry of my first OptiRef. I'm going to select entities, and I'm just going to double click this pocket. Because it sees that whole thing as a feature, it grabbed everything inside of that pocket for me. Then, under toolpath control, I'm going to add a boundary chain. And that's just going to loop around the outside, just like that. Everything else in this toolpath was preset from the other file. My tool has been pre-selected, my speeds and feeds are ready to go. It's got everything it really needs. So if I hit the green check, that's going to regenerate, and it will create the operation that I need for that pocket for roughing, right? The first initial rough. And there we go. There's some things it can't get into because the tool's too big, but that's what these other ops are for. I've got this one. It's an OptiRest with a smaller tool that's based off of this stock model. Then another OptiRest with an even smaller tool that's based off of this stock model. And the reason I stop here is because this tool I know is small enough to hit all of the smallest radiuses that are put on these parts on a regular basis. So with that, I can just hit regen all dirty, and it'll take a moment because this isn't the fastest computer in the world. But I mean, oh, I did forget a step. Oh no, I forgot a step. Here we go. So I'll show you what I did wrong. The other toolpaths still need their geometry. The good thing is you can actually right click and drag from the geometry from the first operation to the second one, then click on replace geometry. It will bring in the machining geometry and the control boundary. I'll do the same thing to the last one because they're all going to use the same geometry, and then regenerate. Now it's working. So what I like about this method is in a few steps, can have all of my roughing done for any board like this, right? It doesn't matter what the specific board is. It doesn't matter. Shelly, could you get that over for me? It doesn't matter what the specific dimensions of this are because I know how the parts behave overall, right? I have a standard flow for how I work. We know what the standard types of features are. So we have our 3 here. There we go. So from our top view, we've got our second tool that comes in, cuts everything that the bigger tool couldn't get, and then again with an even smaller tool. So by the time that stock model's done, we're ready for finished contours, pop a couple holes in it, and we're done. So with a quick computer and some good operations preset, I could probably have this entire board programmed in less than 10 minutes. So I think that's pretty good, right? Awesome. All right, Kyler, if we could go back to the slides. Do we have anything in chat? No? Any questions? No? All right. So next up, loading saved defaults. So this is a feature for Mastercam 2024. And like I was saying before, loading your defaults is something that we've been able to do, but now we can load defaults based on other files. And that's really cool. So this is kind of like import, but it's a little bit smoother, and we don't have to go do as much searching, especially if we have some pretty standard files that we're using for our starting points. So if you have known good settings for your approach, you know what tool you like, you know what kind of speeds and feeds you like, you know your step overs, your step downs, all that kind of stuff, your pattern options, all of that can be preset. And I'm going to show you an example for Mill 3D, but this works for anything. This can work for multi-axis, this works for mill turn, this works for turning, this works for wire, doesn't matter. So yeah, fantastic time savings on this, and I really like this interface. So I'm going to show you guys how this one works. Kyler, if you want to switch back to my screen. Come on, there we go. All right, so I'm going to bring in this file. So here, all I've got so far is a part in a fixture, and I've got a stock model on there just to give me kind of a starting point. And what I want to do first is do an OptiRough from this orientation right here. So I'm going to start an OptiRough toolpath. Now, before I do anything else, I'm going to come up here, and this button right next to the floppy disk icon, this allows me to choose a file to load my defaults from. So if I click that, we have a radio button selector between default or custom. So default is going to pull the default values from your operations default file. But if we select custom, we can pick any .mcam-operations or .mcam file. So even a standard part file. So I'm going to change my selection here. I'm going to go back to my shared Mastercam folder, go to processes, and grab my, oh, actually, you know what? I had this in a different spot. Here we go, default parameters. So when I load that in, what this did is it found any operation that was an OptiRough that was in that file. And with that selected, it says, what do you want to do? So here I have 3 possible settings. I have OptiRough standard with stock. I have Opti large step down, small step over, or Opti large step over, small step down. So these are different toolpaths that I built in the other file for standard approaches that I like to take for this type of work. So with that selected, I'm going to choose the first one, OptiRough standard with stock. When I click OK, this has changed every parameter in this toolpath to match that other one. All we need to do is make sure to double check our tooling. So this is going to use a 3/8 bull end mill. And then we need to reset our model because it won't select your geometry for you. Otherwise, it's the exact same toolpath from the other program, right? That's not very useful. So we'll make our selection. We'll triple click here. I'll probably want to add some avoidance as well, just in case. And steep shallow, I'll probably want to add this in too. Now this is something you could add into the default parameters. If you know that you do this type of work frequently, add steep shallow in as one of the options. I'm going to set this to just go halfway down the part, call it good enough. Everything else in here is fine, and I should be able to just regenerate. Linking, planes top left. There we go. Oh, it's because I have stock. That's why, yeah, okay, so I should have remembered. It said with stock, right? So I have to go set up some stock. So from one other operation, it's this stock model. Now it knows what to do. At least it should. All right, I think that I made a mistake because I tried to push it through without the stock, and it did not like that. That's okay. So we can pop this through again. Again, what's really nice is once I've selected it once, I can hit this drop down, and now I can just pick my options here. So if I wanted that option, select my model. We'll just use remainder, actually. There we go. It's easy. Set up our stock. Double check our tool. Looks good. Yeah, it likes that better. There we go. There's the little circle. Bottom of the stock is above maximum depth. Yep. Okay, and that's fine. So this is a way to quickly bring in all of those settings, right? And what I like about it is, again, being able to just select a different way to do this, really nice, because instead of having to create a new operation or having to fiddle with every set, I can just go in here and pick a different one. And that's even true of an existing op. So once this is done processing, what I can do is go into my parameters and say, you know what, I don't want to do this with a end mill. I want to do this with a high feed tool. So in that case, I might choose small step down, large step over. So I'll pick that. And now all of my settings are different. My cut parameters, I've got a much bigger step over here. My step down's tiny. I can choose my different tool, my high feed tool. It turned my stock off. So maybe that's something you like. And then you just make sure to reset the model geometry. That's all you really have to do. So that's the gist of how loading save defaults works. And I think that if you take the time to really set this up in a way that benefits you, then I think you could save a lot of time. There's no magic bullet with this. I can't give you a file that has all of the strategies because it's useless, right? It only works if you set it up. You have to take the time to do it.
In regards to that, I use a lot of templates, but part of the problem is figuring out what is the smallest radius on the model, what are some of the features. Do you have any model analysis to figure out what is on the part?
Yeah, there are some tools within Mastercam that do that. So we have in here, let's see, so we have dynamic is a little bit manual, but we do have like things like analyze draft angle. So if you're looking for, what are the draft angles of my part, you can use this, and from a given plane, it can tell you what those draft angles are. So that can be useful if you're trying to figure out, oh, should I be using a tapered tool or should I be stepping this up, right? Do I have a tool that works for this? There's also tools. There's some other tools in here that allow you to do things like find the smallest fillets.
Yeah, that's a good one to know.
Yeah. So let's see here. I don't always remember all of these tools myself, I'll be honest with you.
Yeah, that's something I use a lot because it's nice to have the templates made, but if you don't know which one to implement, are you just clicking through templates?
Right, exactly. No, it's good to know what is going on with your particular model. So I do know that there's tools for this. I just can't remember where they are. If Tim happens to be watching, he might put something in the chat and we'll go back over it. Otherwise, I can reach out to you by email afterwards or put this in the recording afterwards as well. All right, Kyler, if we could go back to the slide deck. I think we're just about to wrap up the examples here. There we go. Process hole. So process hole is another new feature for Mastercam 2024. And it allows us to take a hole that is defined as a solid hole, so not an extrusion, and we do need to have the history on that. We can take that, and with that information, if Mastercam knows what that definition is, based on another file and the same definition of a hole, we can bring in a process. That process can include multiple toolpaths, which I really love. That means if you're doing, let's say you're making a hole for a socket head cap screw, and you need to spot this, then you need to drill it, then you need to take an end mill and do your counterbore, and then you want to take a chamfer mill and pop a small chamfer on top. That's 4 operations. As long as you save that as a process within Mastercam, whenever that same hole definition comes up, you can use this tool, say, pick this hole, go, and it will add all 4 of those operations automatically. It doesn't even matter if they're at different depths. It can account for all of that because it knows the solid history. So with process hole, I will say that in terms of getting programming done, it's probably the fastest tool out of all of these that we've seen today, but it's also one that takes the most heavy lifting to set up. It is definitely a bit of work, but if you have any standard holes, this is golden. Absolutely wonderful.
And does this work with most file types? Like a step file will also be able to use process hole, or is this only for things that have history essentially on the build?
So your question was, does this work with any kind of file or does it need to have history? So it does need to have history. However, just because it came from another system doesn't mean you can't have history. You can add history to a model. So Kyler, if we can go back to my screen for a sec here, I am actually gonna kill one of these Mastercams and go to the other one. All right, so I don't actually want to open that one yet. I'm going to open a different one here. I want to go back to that file we were just working with. because this even works in multi-axis, which is pretty cool.
It's the analyze curvature tool.
Analyze curvature. I don't know where that is, but there is Command Finder. Oh yeah, that's where I screwed up. That's why it was taking forever. I forgot the steep shallow. Yeah, analyze curvature. There is a command finder. So if we go in here and go analyze curvature, should be in here. Here we go, curvature, home analyze. So that is something that could give you like your fillet sizes, for instance. All right, so kill that. So let's say we have this part here, right? Let's go take a look at the solid, and the solid body itself. Which one is it? It's probably quite low on the list. Okay, so this is the body for this part, and there's no solid history here. This is a dumb solid. So this could have been brought in from another system, could have been an STL, whatever. So from the model prep tab, you can go to this feature for find holes. Then we're going to select an entity to find holes on, and selection here. And then up here we have some options. So we're going to create hole operations. You have an option to create a single operation. This means if you have multiple holes that fit the same definition, then you can combine them into a single history operation. That's really useful if you have like an array of holes that are all the same. That way you don't have them all separate and, oh, I need to make a change to these holes. Let me do this one at a time, right? That would be awful. So this lets you combine them. So in this case, we have like 4 holes, the front, these counterbore holes. So I'm just going to let this run. And it found 4 holes detected in the body, right? So now I have these 4 counterbore definitions. I can double click into them, and they act just like a normal solid hole function. So if you are working on a model that doesn't have any history, that's the tool you want to use first. Does that answer your question? Okay. So now let's come into this part here. Now I'm using the same part as I did before, but for a good reason. And this one's slightly different in that it's actually a different size a little bit, I think. So I'm going to change my model color again because I do actually like that green. That's nice. Okay, so if we look closely here, we'll see that there is 3 different colors of holes that I want to deal with. We have a red one, yellow, and blue. So the red holes are going to be basic. I just want to punch through them. I don't care. As long as they're roughly on size, we're good. The yellow ones are going to be drilled and then tapped. So I want to make sure that I have both of those operations. And then the blue one is going to be drilled and then reamed, right? And these are operations that you might do frequently if you're doing parts like this all the time, standardized holes. So what you can do for this is you can go up to your toolpaths, and over here you have process hole. And from this, what I'm going to do is hold control and then click this red hole. It's going to find all of the other holes that are within the same solid history item that match. So we got those. Then we go to the process tab, and I want to select a different library. So I'm going to go to my processes folder and select my process hole template. Once I do that, when it loads up, we should see this update. So here it found a process. So this process is a toolpath group within that other file, and it has been labeled for this type of hole. It knows that that process was tied to that same solid hole history type. So it's got the same diameter. If it's got steps to it, the steps all matches the chamfers. This is why it's a little more work to set up, right? Everything's got to match exactly. But when it does, it makes this very easy. So it found that we have a chip break toolpath. Like I said, it's a simple hole. So then I'm just going to set this up as a basic minimum clearance, part clearance 100 thousandths, green check, and we'll just allow that. Okay, so that was pretty straightforward. It's just going to drill it, right? Now let's talk about like the yellow holes. We're going to do process hole again. And I'm going to control click finds those. We go back over here, it pulled in the same template file, and it found a different set of operations for those holes. This has got a chip break and a tapping cycle for 2.5 millimeter holes. Say okay here, and that adds drilling and tapping to those holes. One more time for the blue holes. These are going to be reamed. So this is an M5 reamed hole, peck drill and bore. And done. So, whoops, very sensitive mouse. So all of those holes on screen, if we grab this entire group, all of those were programmed in just a few seconds because I had a process hole ready to go. So if you're willing to spend a bit of time putting that together, it's definitely worth it. Now, how to build that, we don't have time to go over today, but we do have videos coming out on our new knowledge base that will detail how to do this exactly. So if you want to learn about that, make sure to go to our website and look for the knowledge base. It's going to be full of lots of great information. We've been adding tons of articles to that thing. All right, Kyler, if you want to go back to the slides. Okay, so there we go. Using libraries for quoting. So if we take everything that we talked about today and use them in combination, I'm sorry, what's it?
Have a question.
We have a question. What's the question?
The question is there an advantage to using process whole versus importing a Mastercam file that has the entire sequence of operations?
Yes, so the question was, is there a benefit of using process whole over just importing a bunch of operations? And one of the big benefits is that you only have to select the geometry once. If you do the import, you have to pick the geometry for each of those or do the geometry replace, which is a lot more steps. Number two, process whole is a little bit more flexible in terms of if the depths of holes are changed, it's more effective at actually picking that information out because it's using the solid history. And then the third point is that it is easier to use for multi-axis. If you have multi-axis drilling, it is easier than trying to import. It's got settings. The settings are baked in a little bit better. Did we have anything else?
Nope, that was it.
Any other questions out here? Oh, nothing? Okay. All right, so using libraries for quoting. So if we take everything and we kind of put it together, what we get is a set of files, operations, and processes that can be used to program basically anything in our shop quickly, right? Whether you have a operation set for something you do frequently, or if you just know your tools and materials pretty well, and you could be making anything, you could import the defaults, right? Or, you could use process whole. If you're doing a lot of holes, you can get that sort of thing done. By using these together, you can quickly determine what is it going to take for you to machine something. And you can get an approximate cycle time and tooling use in just a few minutes if you have everything set up correctly. So I think that this is really going to change quoting, because if we're otherwise trying to quote, it's based on a lot of experience and just knowing what things kind of look like and making your best educated guess. I mean, kudos to the people who are really good at that. I'm not. But this is something I can use on a daily basis. This is something that I can teach someone else how to use who isn't necessarily a programmer and get a result that's at least kind of close and know where to go. So I think it's a great set of tools to use for the purpose of quoting. Oh, we're back to the slides. Awesome. You could move forward. So that kind of wraps it up for the prepared stuff that I had for you guys. A couple of quick announcements. So August 9th, we're doing another webinar. We don't exactly know what it is yet, but that one's not going to be hybrid. That'll just be online only. So make sure to get signed up for that. Look for our newsletter. August 16th and 17th, we're going to be at the Haas Factory Outlet in Boise/Meridian. I think it's Meridian. So we'll be out there. So you guys are all local, but you may not be. So, maybe come check us out there. And then September 13th, we're doing another event like this at Chemeketa Community College. We're going to have different topics. It's going to be a completely different thing, but same sort of approach. Kyler, move forward. And with that, is there any other questions? I would love to sit here and talk with you guys. Bye, Shelly. Do you guys have any other questions? Even if they're unrelated, that's cool. Anything in chat?
Good job and great info.
What's that?
Good job and great info.
Oh, okay.
How is yours? So I'm setting up on a 5-axis, frequently dovetail the blank to get an initial grip. How do you go about setting up your stock model efficiently? Because, I mean, we have to make stock for every single part, and it kind of matters centering the dovetail in the blank or offsetting it, and all of those clicks involved in creating that initial model. Is there any time savings that you have?
Sure. So the question is, and I'm repeating it so that they can hear the recordings and all that. So the question is, if you're doing a lot of like dovetailing, for instance, and you need to make sure that that is represented accurately in a stock model, is there a way to do some good time savings? I would say yes, there is. Kyler, if you want to go back to my screen for a second. Now, I don't have anything pre-built for this because I don't set up a lot of 5-axis machines myself. I pretend to set up 5-axis machines by myself. So let's turn on my axes for a second. So I'm just going to do a quick sketch here. So your dovetail might look something like this. I went overboard. I'm sure these angles are wrong, right? And then you've got more on top of that. So let's say it's some kind of a block. This scroll wheel, Kyler, I don't know how you use this.
What are you trying to do?
Your scroll wheel, even with the clicky mode, it flies. And then you have some block, and it's you know, way taller than this or whatever. All right, and then we'll trim everything together. Okay, so if you have some standardized widths of your dovetails, save something like this, where you can just take those angles and shift them around as needed, then create the rest of your profile and extrude that into a solid. That can be used as the basis for your stock model. So just by having a sketch that's similar to what you're looking for, that's quick and easy to modify, I think that's a good way to do it. You can highlight and use, you know, dynamic transform, snap it, and then you can just use a reference point or something to get the width that you're looking for. Then you just use trimming tools to trim everything back up.
That's not bad. You don't have any parametric modeling as far as user parameters, like so I'm going to be honest, I'm a Fusion user, so I'm in the wrong
Fusion
place.
guy.
I'm in the wrong place. But there's plenty of parametric modeling within Fusion utilizing, like, so if I have a pre-extruded geometry, I can go back to the sketch, but within just a separate function form. So I can type, I labeled this dimension as dimension 2, and it is stock width. I can type any number in there, click generate, and it regenerates the stock at whatever stock width. Are you guys utilizing any of that function-driven modeling?
Yeah, so we do have associative modeling, and so it does the same thing in a different way.
Okay.
So as opposed to having some dialogue that's a bunch of fields and forms, everything is visual with Mastercam. We program things visually. So for instance, let's see, are we still showing? Cool. So what I'm going to do here is I'm going to go to solid, extrude, pick that, and flip that around, and okay, so that's my solid that I have, right? Now, if I wanted to modify this, I can just modify the wireframe, and then the solid can update from there.
Right.
So for instance, I can go to my transform, and I can go to, say, stretch. Select those, pull this up. So I want to bring it up to there, let's say, green check. Now, if I go to my solid, you'll see that the solid doesn't follow the wireframe here, but as soon as I regenerate, I'm good to go. So you can modify your wireframe in any way you like. And as long as that chain still exists and you haven't broken it, the solid can regenerate itself. Does that make sense?
Yeah, that's pretty good.
So it in one way, yeah, it doesn't give you the fields that you're looking for, but in another way, it gives you more flexibility because now I can kind of go any way I want with this, as opposed to I have fields that tell me which way I can go.
But could you put the bottom piece on a process and say, coming in there with a 1/2-inch end mill and cutting the part and then using the AB, cutter to cut the dovetail, and just make that as a process. And then each time you have a different block, it would figure out how many cuts you need to come in there with that 1-inch end mill or 1/2-inch end mill, and then finish it with the AB cutter.
Yes, absolutely. You could totally do that. So it would take me a minute to build it, so we'll probably not do it right now, but it is a process that you could make where you basically have a toolpath tied to the solid. And if the solid changes, the toolpath is associative to that, so it will regenerate.
Yeah, that's kind of my workflow. And I was curious if you
Yeah.
have the same problem.
It definitely does do that. Yeah, it's been around for years. We've had solid associativity in toolpaths for longer than I've been doing this.
Yeah,
Yeah, it's,
the only thing you'd have to do is you just have to rechain whatever your furthest in point of where you're going to drive your QC cutter with or your dovetail cutter with. You'll just have to redefine that geometry.
You wouldn't necessarily have to. It depends on your modeling process. So if your modeling process includes you shifting things as opposed to redrawing them, then it will still follow it even if you shift it around.
so moving a contour doesn't break it from the selection.
Correct.
Learn something new.
Yeah, yeah. Yeah, no, there's a lot that Mastercam can do with associativity.
That was like my number one concern is because I haven't touched Mastercam in 5 years or so.
Yeah,
And
so
I
like,
didn't have a lot of modeling involved with it, or at least that I was aware of when I was using it.
sure. So like my favorite example for how this works, let's draw, I'm going to draw something here where I have a pocket. Oh, whoops, that's not what I meant to do. I'm going to draw this pocket in here. I'm actually going to shift this up. I miss my 3D controller. I did not bring it with me today. Although the GView Cube is a great substitute, honestly. Okay, so then I'm going to fillet chain just so it's nice and rounded. And then I'm going to solid extrude that guy down. We're going to do a cut. We're going to go halfway down. Okay. So then I'm going to create from the height, same as that, wireframe circle. Okay. I know that this takes a second here, but it'll show exactly what this can do, which is really good for family of parts and stuff like that. So this is going to be an add boss. Okay. So at this point, if I were to take a toolpath like a dynamic mill, and let's say I want my automatic region to be based on this from outside, and I'm going to grab a tool that's like a 1/4-inch flat end mill or something. Linking parameters, absolute, incremental, yeah. Let's set this to like, I don't know, 1 inch. Turn that off. Okay, so I've got a toolpath that's based on that pin being there in a pocket, right? Now, if I go to my model prep and I remove the history on this guy, or even if I take my wireframe and I use dynamic, if I shift this, let's say I shift it to a 1/4 inch or 1/8 of an inch that way, and 1/4 of an inch that way. So you can see my wireframe is moved. Hit the green check. Solid goes dirty. I regenerate that. Now the toolpath goes dirty, and now I can regenerate that. So it's following the solid edges. The wireframe we use to define the solid, but the solid itself is what drives that toolpath. So it's really, there's some really cool tricks. This is like the most basic way to think about it, right? But if you've got a lot of associativity going on, it doesn't really matter what changes in your part. The toolpath can compensate for it. Cool.
Thank you.
Does that answer your question?
Yeah.
Awesome. Anything else in chat?
A lot of Spanish.
A lot of Spanish? Do you read Spanish?
No.
Okay.
Gary's taking care of it.
Oh, yeah, he would. Awesome. All right. Did you guys have anything else for me? Are we ready to get some lunch?
Yeah.
I like sandwiches. So, did the lunch come in? Sweet. Awesome. Okay, Kyler, if you want to just go back to the slides, and we'll just wrap this up real quick. Awesome. So, oh, is that the last one? I forgot how I did it. Okay, anyways. So thanks for joining us today. We really appreciate it. If you guys were not here in person, you missed out. We had lunch. It was great. And this has been a lot of fun. So we're going to do another one of these in September at Clackamas, and I'm sure we're going to be coming back to Chemeketa for more events like this and bigger ones. It's going to be a lot of fun. So with that, I think we're going to go ahead and call it a day. Thanks for joining us, and we'll see you later.